Hey everyone, welcome back to another CIE A Level Math past paper video. Today we're going to talk about the P4 exam, paper 4-1 variant from the May-June 2025 series. So let's jump into the paper. Question number 1. A block of mass 12 kg is being pulled by a rope up a rough plane. The plane is inclined at an angle of 20 degrees above the horizontal. So basically, sort of like this. This is the block of mass, and it's being pulled up by a rope, so that means the tension would be upwards. Mass is 12 kg, so the weight would be 12 g downwards. Okay, let's continue. The rope pulling the block is parallel to the line of the greatest slope of the plane. The coefficient of friction between the block and the plane is 0.4. That means there is going to be a friction additional to the component of the weight also. Okay. Acceleration of the block is 2 meters per second. Okay. So we have a reaction force over here, R. The component of the weight perpendicular to the slope is 12g cos of 20, and the component of the weight parallel to the plane is 12g sine of 20. Right? Okay. So now we need the sum of forces equals to MA tension minus friction minus 12g sine of 20 equals to 12 times by acceleration. Okay. F is equal to mu r, the limiting value, and where r is 12g cos theta. Okay, so therefore this would be 0.4 times by 12 times by 10 times by cos of 20. Okay, so so your friction value is 0.4 times by 12 times by 10 times by cos of 20. This becomes 45.105 friction. Actually, we should keep it this way as best as we can. Right, okay. Now we make T the subject. You have 12 times by A, acceleration is times by 2, plus friction, which is 0.4 times by 120 cos of 20 degrees, and plus 120 sine of 20 degrees. That's it. So mu r mg sine theta, right? Mg sine theta, tension, right? Okay, so that's basically what we need to know. So 24 plus 0.4 times by 120, 120, we are actually redoing the same thing, cos of 20 plus 120 sine of 20 degrees. So tension is 110.148, which is to three significant figures, this would be 110 newtons. And that's it for this question. Let's move on to the next one. Question number 2. Three coplanar forces of magnitudes P, 5, and 10N act at a point O as shown in the diagram. The resultant of the three forces has magnitudes Q newtons and acts in a direction perpendicular to the force of magnitude p newtons. Okay, so this is perpendicular to the direction p, so we don't know whether it's in this direction or it's in this direction. Okay. Find the values of p and find the value of q. Alright, so we can actually figure this out. So let's resolve the 5 Newton force. So this is 5 cos of 60 degrees. This would be 5 sine of 60 degrees. This is 10 cos 30 degrees. And this is 10 sine of 30 degrees. Okay. So sum of forces in y, that means vertical forces, like direction, let's say this is the direction y, this is direction x. So sum of forces parallel to the y that are p plus 5 sine of 60 minus 10 sine of 30. Okay. And okay, sine of 60 is 5 minus 10 and plus p. Right, okay. So sine of 60 is under root 3 over 2. And sine of 30 is 1 over 2, sorry, 10, 1 over 2. So you get p plus 5 root 3 over 2 minus 5. Okay. This is your sum of components, sum of the forces in direction x. Sorry, y. Now the direction x. So 5 cos 60 minus 10 cos 30. Okay, cos of 60 is 1 over 2. Cos of 30 is under root 3 over 2. So this becomes 5 over 2 minus 5 root 3. Okay. Now the only clue that we have is that it acts in direction perpendicular to the force of magnitude Pn. Right? So that means there is no component perpendicular to Pn. So if the resultant itself is in acting direction perpendicular to the force Pn, that means it's parallel to this direction. That means there is no resultant force in that. Since the resultant force acts perpendicular to f of y, sigma f of y is 0. So that means we get p to be equal to 5 minus 5 under root 3 over 2. Okay, so we can further simplify this. We get 10 minus 5 root 3 over 2. That is our p. To find out q, we already had this q. Okay, so q is equal to sum of forces in f of x. 5 root 3 would be greater, right? So this would be x minus 5 root 3 plus 5 over 2, which can be written as minus 10 root 3 plus 5 over 2, that means the value of q, magnitude q, right? So is that. So therefore q is the difference part of that. So minus 5 root 3 plus 5 divided by 2, that is minus 6.16, so that is 6.16. Actually we could do the negative thing also, like 5 minus 10 root 3 divided by 2, or 6.16. Right, so this is also what we can do. Just to confirm that that's what we had. 5 minus 10 root 3 divided by 2. Yeah, that's, sorry, that was the same thing. Minus 5. That's what we actually needed to do. Alright. Therefore P is that value. We can write for P also. 10 minus 5 root 3 over 2. 10 minus 5 root 3 divided by 2. 0.669, so 670. Right? That's about it. Okay, so basically we have written two forms of answers. The exact forms and the inexact forms also. But either way, that's fine. Any other thing? No. Alright, so let's move on to the next question. Question number 3. The diagram shows the velocity time graph of the motion of a cyclist. The graph consists of 3 line segments. Cyclist passes a point O with speed 3 meters per second and then accelerates for 10 seconds with constant acceleration 0.5 meters per second squared. He then travels at a constant speed for 30 seconds before decelerating, coming to rest at point P, covering a distance of 80 meters while decelerating. Okay. Find the total time taken for the journey from O to P. Okay, so that means we need to find out the distance covered while decelerating. So, right, okay, so basically we need to figure out this thing, the velocity first. The velocity, the maximum velocity of this, right? So v equals to u plus at. Either we can do it this way, or that we know the gradient of this line, which is 0.5, v minus u, that is, let's say v minus 3 divided by 10, which is basically the same thing as this thing. Acceleration, so basically this is 3 plus 10 times by 0.5, so 3 plus 5, that is 8. So that is 8. Okay. So distance covered, distance in deceleration, distance while decelerating, is 80 meters. So therefore, you see the area under this graph, let's call it capital T. So we just need to know the time duration, right? So we have area under the curve, half times by, we don't know the decelerating, we don't need to know the deceleration, right? So the height of this triangle, which is the change in velocity, that is 8. And we need to know the t, that is equal to 8. So t is equal to 2 times by 80 divided by 8. So 8 times by 10, so that is just simply 20 seconds. So therefore t, total time for journey, is 40 plus 20, 60 seconds. Okay, good. On your given axis, sketch a displacement time graph for the cyclist's journey from 0 to P, showing on your graph the distances traveled after 10 seconds and 40 seconds. Okay, so first off, we need to calculate the distances in this region. So distance from 0 to 10 first. Let's first calculate that. So distance from 0 to 10 seconds, S would be half times by 3 plus 8 times by 10. Initial, final, right? So you have 2 times by 5, 8 plus 3 is 11, so 55 meters. Then you have from 10 to 40 seconds. That is a straight line region, that is a horizontal region, so that is going to be VT basically, so simply. So V is 8 times by 40 minus 10, that is just 30 seconds. So 240. Okay, 240 meters. And then we have 80 further meters. Okay, so if we from 40 to 60, S is further 80 meters. So total displacement. Oh no, wait. Was this a speed time or a velocity time? That's point OD accelerates for 10 seconds with constant speed, then travels at a constant speed of 30 seconds before decelerating, coming to rest at point P. Okay, so there's no so since the velocity is not changing signs, that means it is still moving in one particular direction. That means in the positive direction. That means the displacement doesn't even start to turn back. Okay, so that means displacement is in one direction. However, the acceleration and deceleration, we have to make that very carefully. So acceleration means the gradient of the graph is increasing. So first off, let's zoom out a bit. Let's make straight lines just to indicate 10, 40, and then there is 60 also, 10, 20, 30, 40, 50, and 60. Okay, how long do we have to go from O to P? Okay, and the total distance is 55 plus 240 plus 80, 375. So roughly we needed 400 roughly, you can say. So if this is, we need to be a little bit methodical about what we are actually trying to accomplish. So if this is 400, okay, then halfway between this would be 200, okay, then halfway between this would be 100, 300, okay, we need it up to 375, so this is 350, and halfway between that would be 375. We just need to know that, like, a few lines over here, the rest we can accomplish. So 55 first. So 55 is like, okay, first This is not the exact, I have made it slightly, there will be slight changes, like slight differences in between them. So 100 from 0 to 10 is 55, and this is the accelerating phase, right? So if this is 50, so 55 would be very slightly above that. So like this, oh no, wait, sorry, like this, slightly. So we can say this is 55. Then we have a further 240, so that means 55 plus 240, this would be 295, so roughly close to this thing. Okay, so this is now going to be a straight line region because the velocity is constant, so very slightly below that. So 295. Actually, we should write 295 over here, right? Okay. And then it's decelerating, right? Up to further 80 seconds. So plus 80, 375. So 375 would be right over here, so decelerating like this. Yeah, so basically like this. Now we can erase the lines. Oh, sorry. We just need we don't need this. We don't need this. We don't need this. We don't need this. We don't need this either. We don't need this. Actually, what we can do is, yeah, so we just need a dotted line over here, so we will just make it with the, oh sorry, oh wait, 375. We can trace it over here, 375. Right, and now we can erase this one. Technically the vertical ones will have to be dotted ones also, so let's make them dotted. That's about it. And that's about it. So final thing I forgot to write over here is 60. And that's about, yeah, okay, so that's it. Total displacement is 375 meters. And we can delete this 100 also. This one also. Technically they only asked for 55 and 295. Alright, okay, let's move on to the next question. Question number 4. A lorry of mass 18,000 kg is traveling along a straight road. On the horizontal section of a road, the power of the lorry's engine is constant. There is a constant resistance to motion of 1600 newtons. The steady speed of which the lorry can maintain with the engine working at the power p watt is 30 milliseconds. Find the value of p. Okay, so steady speed, that means there is no resultant force on that. So that means the engine power would be equal to the power worked against the resistance of the motion. So this would be just simple. P is equal to 1600 times by F, we just simply 30. Okay, so 1600 times by 30, that is 48,000 watt. Okay, At an instant when the speed of the lorry is 16 meters per second, the engine is working at a power of 40 kilowatts. Define the acceleration of the lorry at this instant. Okay, so we can figure this out also. So you will have F is equal to ma. Okay, so basically we need to figure out the force in fact. So there's a constant resistance to motion, right? So power P minus 1600 times by 16 meters per second. Okay, so this is the net power, right? So this P is currently 40,000, so 40,000 minus this, that is your net work. Okay, so net power, sorry, the power is the used power basically. So that is 40,000 minus 1600 times by 16, that is 14. Okay, so this is your force, right? No, this is just power, right? So this is your useful power basically. So force would be 1400 divided by 60. So this divided by 16 is 900 newtons. Now we can employ the F is equal to ma. That is actually the net force over here. So acceleration would be 900 divided by 18,000. .05. That's it. When the lorry has reached a speed of 20 meters per second, it begins to ascend a section of road inclined at an angle alpha to the horizontal. Engine now works at a power of 120 kilowatt. There is no change in the lorry's speed as it ascends the hill. Constant resistance to motion remains 1600 newtons. Find the value of alpha. Okay, so remember now that the power developed by the engine will be counteracting the work done against gravity also, as well as the work against the resistance also, right? So the P actually is working against the FV also, that is the mg sine theta, right? So mg sine alpha degrees times by V plus the 1600 times by V also. Okay, so that's what we have. So we have 120,000. mg is 1800,000 because we had 18,000 kgs. So 18,000. So 180,000. Sorry, this will become 180,000. Thank God I just realized that. Okay. V is 20 sine of alpha plus 1600 times by 20. Okay, so we just need to figure out what sine alpha is. That is 120,000 minus 1600 times by 20 divided by 180,000 divided by 20. That is 0.0244. So alpha would be sine inverse of this value, you get 1.4 degrees. And that's it for this question. Let's move on to the next one. Question number 5. When a particle P of mass m kg has speed u meters per second, its momentum is 4 newtons second and its kinetic energy is 16 joules. Find the value of m and find the value of u. Okay, so we know that momentum is mv and ek, which is half mv squared, can also be written as half p squared over m. So momentum value is given. So first we can figure out the momentum. So this is 16 joules equals to half times by 4 squared over m. So therefore m would be 16 times by 2. Actually the 16 and the 4 squared will just cancel out, so this is just 2. No, 1 over 2, sorry. 1 over 2. Right? Right, okay. And then we find out P, which is going to be 4 newtons second. Mass is 1 over 2. V is unknown, so V is going to be 8. So therefore, M is 1 over 2, V is 8. Okay. P is now projected on a small horizontal surface with speed v meters per second directly towards a particle Q of mass 1.25 kg, which is stationary. After P and Q collide, the velocity of P is w meters per second, the velocity of Q is 2w meters per second. The loss of kinetic energy in the collision is 25 joules. Find the value of V and find the value of W. Okay, so first off, we know the principle of conservation of momentum, which is mp up plus mq uq equals to mp vp plus mq vq. Alright, so that is P was mass 1 over 2, 0.5. Speed was V. MQ was stationary. Now 0.5 is velocity W, and this is 1.25 is 2W. So plus, okay, I think we can make it in as an equation in one of the variables. So this would become 1.75, so V would be 1.75 W over 0.5. So 1.75 divided by 0.5, that is 3.5. No, sorry. This is 1.25 times by 2, sorry. 0.5 plus 1.75, sorry, 1.25 times by 2. This is 3, sorry. 3. So 3 divided by 0.5, we already know that's going to be 6W. Okay, because that's going to be 3 times by 2. Alright, now the loss of kinetic energy in the collisions. Okay. So change in kinetic energy is 25 joules, net kinetic energy, right? So half m v squared minus half m w squared plus half 1.25 2w whole squared. Okay, so let's simplify this. This would be 1 over 4 v squared minus 1 over 4 omega squared minus 0.5 times by 1.25 times by 4. This is 2.5. Can rewrite it as, which we can rewrite it as 10 over 4 omega squared. This is equal to 25. So first thing that we can do is convert v into 6 omega and then times this by 4. So you will have 36 omega squared. Sorry, this is w, sorry, not omega. W squared minus 10 squared equals to 100. 35 minus 10 is 25 is equal to 100. So therefore omega squared is 4. So w is again just 2, v being 6w, that is going to be 6 times by 2, which is going to be 12. Alright, and that's it for this question. Let's move on to the next one. Question number 6. Two particles P and Q of masses 0.3 kg and 0.6 kg respectively are attached to the ends of a light inextensible string. The string passes over a smooth pulley fixed at a point B where the inclined planes AB and BC meet. P lies on a smooth plane AB which is inclined at an angle theta degrees to the horizontal, where sine theta is 0.4. Q lies on the plane BC which is inclined at 30 degrees to the horizontal. String is taut and the particles can move on the lines of rate of slope of 2 points. Particles are released from rest. It is given that the plane BC is smooth. Find the tension and the string and acceleration of Q. Okay, so we just need an arbitrary direction over here. So let's assume that Q moves downward. So that means tension is this way, tension is this way. We are assuming acceleration is in this direction. If it's not, we will get that corrected anyway. Okay, so the component of weights in this direction, that is 0.6 g sine of 30, and for this one this would be 0.3 g sine theta. Okay, sine theta is given as 0.4. Right, okay, that's it. Okay, so we have 0.6 g, actually we can just simply write it 0.6 g sine of 30 minus tension is equal to 0.6 a. Let's we can simplify this to be as 6 sine 30, 0.6 times by 10 times by sine 30. 6 divided by 2 is just 3 minus t equals to be 0.6 a. The other equation for Q is, sorry, this is Q. Now for P we need t minus 0.3 0.3 g sine of theta. This is 0.3 a, so this is going to be t, and 0.3 times by 10, 3 times by 0.4, that is 1.2. minus equals to 0.3a. Okay, so now we can solve the two equations simultaneously. So this cancels out. 3 minus 1.2, 1.8 equals 2, 0.9a. So a is basically just 2. And now we can find out t is equal to 0.3 times by 2 plus 1.2, 7.2. Because 0.3 times by 2 is 0.6. Actually, we were right. Just to confirm. Sorry. So, okay, alright, my bad. Yeah, sorry, my bad. 1.8. Right, okay. That was 0.6 plus 1.2. Alright, okay, my bad. That's it for the tension. That is the acceleration. So therefore tension is 1.8 newtons and acceleration is 2 meters per second squared. Okay, alright. It is given instead that the plane BC is rough. The work done against frictional force when Q moves 2 meters down the plane is 1.8 joules. You should assume that P does not reach the pulley and Q does not reach C. Use an energy method to find the speed of Q when it has moved 2 meters down the plane. Okay, so to understand this, we have to remember that there is a change in potential energy, net change in potential energy. There is a work done against friction. Okay, and then there is a net change in kinetic energy. That's what we need. Net change in potential energy will come from the height changes. Okay, so the the distance they're traveling along the plane are 2 meters, but the height change for P, for example, this would be 2 sine theta. Sine theta is 0.4. So 2 times by 0.4 is 0.8. This is just the change in height. Similarly for this one, that is going to be 2 sine 30. This is sine 30 is just 1 over 2, so this is just 1 meter straight down. However, this is not the change in potential. The change in potential would be something else. Since we are saying loss and gain, loss in potential, gain in kinetic, so we are moving downwards, right? So we will take the direction of Q to be the positive one. So mgh 0.6 g um, 1 minus 0.3 g 0.8 minus 1.8 equals to half. Since it started from rest, we just need that. Mass, since they're connected particles, so their masses will be added. 0.6 plus 0.3 v squared. Okay, 0.6 is the 0.6, actually 0.6 times by 10 is just 6, minus 3 times by 0.8, that is 3.6, minus 1.8 is 1 over 2, 0.9 v squared. 3.6 minus 1.8 is 1.8, so 2 times by 1.8 over 0.9 is v squared. This is like simple times by 2, so v squared is 4, so therefore v is just 2. And that's about it for this question. Let's move on to the next one. Question number 7. A particle x moves along a straight track starting from point O at time t is equal to 0. Displacement of x from O at time t seconds is s meters, whereas this is find the time at which x is instantaneously at rest, and hence find the total distance traveled by x between t is equal to 0 to 16 seconds. Okay, so we need to figure out where he's instantaneously at rest, where velocity is 0. That means we need to figure out where ds over dt is 0. So ds over dt power comes down 3t, and 1.5 minus 1, that is 1 over 2 minus 6 equal to 0. So okay, so we need to figure that out. 6 goes on the other side, times by 2, 6 times by 2 divided by 9, 12 divided by 9. Okay, so this becomes 12 over 9. Right, so remember this is the square root. So we square both sides. So we get t is equal to 144 over 81. So let's see if we can get that. 16 over 9. Okay. Right. Now it is possible that wherever it's changing, it says like a turning point, velocity is changing sign at that point. So that means the displacement is turning back, but the distance will need to be added. So to find the total distance, we need to add the distance slightly differently. Hence find this is the displacement of x, right? So first we need the displacement up till, okay. So s of 16 over 9, basically this is a function, right? So 3t, sorry, what was it? 3 over 2. Minus 6, 16 over 9. Okay, so you get 3 times by 16 divided by 9 raised to power 1.5 minus 6 times by 16 divided by 9. This is, okay, so as you can see, the displacement covered in this section, this part is negative. So this is minus 32 over 9. Okay. Then what we can do, from 16 over 9 to 16, so basically we can figure out the total net displacement. This would be 3 over 2 minus 6 16, like that. So 3 times by 16 raised to power 1.5 minus 6 times by 16. This is 96. Now to understand how to go further than this, 16 over 9, let's say for example this is the thing over here, from 0 to 16 over 9, the area is negative, and this is your area that is positive. The net area, that means this the positive area minus the negative area, when we add them we get 96. We need to figure out, we need to turn this negative into positive, right? So simply that's what we need, right? So we will just simply do total distance. Now for total distance, we can't just simply like add 96 with 32 over 9. We have to employ a different method. So what we do now is we know that the net sum of these is 96, right? So like 96 minus 32 over 9. We need to figure out what is this particular area, right? Up to 16. So we need to figure out that. So between 16 over 9 to 16, so we can figure out so 96 is basically, let's call it the 32 over 9, we already know that, let's call it area 1, let's say. So area 1 minus 32 over 9, so area 1 is 96 plus 32 over 9. So 96 plus 32 divided by 9. This is 896 over 9. Okay, so notice that this is just this area. Now for total distance, all we need to do is, actually sorry, I already wrote it above. So total distance would be 32 over 9 plus 896 over 9. So 896 plus 32, 928 over 9. Is there any further simplification of this? Yeah, okay. So 103 meters. Okay, that's it. And right. The second particle y moves along another straight track starting from a point P at time t is equal to 0. The acceleration of y at time t seconds is a meters, where a is this. The velocity of y when it leaves P is 7.5 meters per second. When the velocity of y is minus 9.6 meters per second, show that the displacement of x from O is equal to the displacement of y from P. Okay, hold on. So it's starting from a point P, right? It's starting from point P. Oh, they're talking about different things. Okay, so x from O and equal to P from y from P. Okay. So at this point, this is minus 9.8, 9.6. The acceleration of P is 0.8 minus 0.6 t. E when it leaves P is 7.5 meters per second. Okay, right. And from O, the x, this is your y. Now the x was when the velocity of y is minus 9.6. So the displacement would be equal x from O. This is the displacement equation, right? 3t over 2 minus 60. Okay, so basically we need to figure out how much time this particular thing happens, right? Okay. So first off, we need to integrate acceleration. So this would be 0.8 t minus 0.6 t squared over 2 plus c. Okay. So at t is equal to 0, v of y is 7.5 meters per second, right? Okay. So therefore the v of y becomes 0.8 t minus 0.3 t squared plus 7.5. Okay. And now we need to know at which time it becomes minus 9.6. Okay, so we equate that. So t minus 0.3 t squared plus 7.5 minus 9.6. Okay, we bring it on one side, so this is minus 0.3 t squared plus 0.8 t, 7.5 plus 9.6, 17.1. So we change the signs. Minus 0.8 t minus 17.1 equal to 0. Now we need to simply do quadratic equation. So t is equal to 0.8 plus minus b squared minus 4 ac okay divided by 2 times by 0.3. Okay, so now we need the values. So 0.8 plus square root of 0.8 squared plus 4 times by 0.3 times by 17.1 and 2 times by 0.3. So one answer is 9. If the other answer is negative, we cannot accept it because obviously time cannot be negative. So time is 9, so therefore displacement of x in t is equal to 9 seconds. We need to see that actually wait, we need to further integrate this also. Okay, displacement of, first we do y, so then we need to integrate velocity function also. So velocity function is this becomes 0.8 t squared over 2 minus 0.3 t cubed over 3 plus 7.5 t plus c. Okay, then what we just simply do is we need to figure out what the sy is at t is equal to 0. So it's starting from point P at time t is equal to 0, so we can assume that displacement is 0. So therefore at t is equal to 0, sy is equal to 0, so therefore sy is 0.4 t squared minus 0.1 t cubed plus 7.5 t. So at t is equal to 9 seconds, sy is equal to 0.4 9 squared minus 0.1 9 cubed plus 7.5 9. This would become 0.4 times by 81 minus 0.1 times by 9 cubed plus 7.5 times by 9. This is 27. Now we need the same thing of x, displacement of x in t is equal to 9 seconds. This was 3t, 3 over 2 minus 6t. So 3, 9, 3 over 2 minus 6, 9. So 3, 9 raised to power 1.5 minus 6 times by 9, 27. So that's we have shown. Therefore, displacement of y in 9 seconds is same as displacement of x and is equal to 27 meters. That's it. And that's the end of this paper. Hope you enjoyed solving this paper with me. If you have any doubts or confusions, feel free to reach out in the comments. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. I also offer one-on-one sessions for personalized preparation sessions. So if you are interested in preparing for May June 2026 exams, feel free to reach out through the WhatsApp or anything. The links are given below in the description. Until the next video, take care. Bye bye.